Dear students, in last class we studied the effect of ice and wind on line conductors, and also we have solved a problem based on calculation of sag and tension when there was ice deposition and wind blowing onto the conductor. Here are some homework problems which you have to write down and solve on your own. Problems. First problem, you have to write down and solve. Here is second problem. Third problem. Fourth problem. Exclude fifth one. And these questions may appear in your IA, that is internal assessment, or semester and examinations. Dear students, now I will take up the last topic of the first chapter in second unit, that is stringing chart. This chart is so called because it is used for stringing the conductor between two supports. Say for example, these are the two supports and these are cross arms. To string the conductor between the supports, the stringing chart is used. That is why the name is given as stringing chart to the chart that you are going to study now. In the stringing chart, two curves are drawn. One curve is for sag versus temperature. Other curve is for tension versus temperature. It is the direction of increase of temperature. Here we must understand that a conductor is made up of metal, maybe aluminum, copper, steel, etc. When it is subjected to increase in temperature, the conductor elongates, and hence between the supports the conductor will come down. It means that as the temperature increases, the conductor comes down more and more, or you can say sag increases, or you can say sag increases. When the sag increases, that is, a conductor is loosely lying between the supports, then there will be less tension at the supports, which means as temperature increases, tension decreases. With this idea, we can draw the graph here. So as temperature increases, sag increases. As the temperature increases, tension decreases. This way. This stringing chart is helpful in providing sag and tension at any temperature. If the sag and tension are known for a particular temperature, the curves of sag and tension with temperature variation are called the stringing charts. And these charts are useful in erecting the transmission line conductors at specified temperature and loading conditions. Stringing chart is helpful in providing sag and tension at any temperature. If the sag and tension are known for a particular temperature, the curves of sag and tension with temperature variation are called the stringing charts are called the stringing charts. And are useful in line conductors, line insulators, supporting towers, at specified temperature and loading conditions. Along with this, I also advise you to remember the empirical formula used for finding out the distance between the two conductors in transmission lines, or the spacing between the two conductors in transmission line. See, for example, these are the three conductors. Say, for example, these are the two conductors. How much should be the distance between these two conductors is decided by sag and the line voltage at which these two conductors are operating, and that is given by sag. In the derivations, sag is denoted by small d. That d you can use here, plus V upon 150, where V is line voltage. So this is spacing between two conductors. Next formula is for calculating ground clearance. Ground clearance means At what height from the ground the conductor supported by two towers should be placed? This is ground clearance if these are leveled supports. This GC is calculated as six meter plus 0.01 meter per kV, which means that 6 meter is for any conductor operating at a voltage less than 1 kilovolt. If line operates at more than 1 kilovolt, then its height must be increased 0.01 meter per kilovolt for the safety purpose, for the purpose of economy. Dear students, now I will take up the second chapter in second unit, Corona. To understand corona, let us consider two conductors placed in air medium d meters apart. Here is conductor 1 and here is conductor 2. Let us say these two conductors are transmitting electrical power with a potential difference of V volts between them. If we increase the potential difference between these two conductors, then at some potential a faint luminous glow of violet color will appear adjacent to the conductor surface with a hissing noise. That means around these two conductors you will find faint luminous glow of violet color, and there will be hissing noise. You know what is hissing noise? Snake hisses. The sound produced by snake is called hissing sound. So like that, the sound will be produced by the conductors. Also, around these conductors there will be formation of ozone gas. The ozone gas will be produced around these conductors. When this happens, if we further increase the potential difference, the intensity of glow and noise will increase. The intensity of the glow will increase along with the noise, that is hissing sound. This phenomenon is known as corona. This phenomenon is known as corona. And this corona is due to the ionization of air near power conductors, because these two conductors are placed in air medium, and the air between these two conductors as well as around the conductors will be getting ionized. Since free electrons are normally present in the free space due to radio and cosmic rays, these electrons get accelerated due to the voltage of power conductors and collide with other molecules of air, and they dislodge electrons from molecules. In your 12th standard, you all have studied that there exists a field around a charged body. Now here, the two conductors carrying current will be having charges flowing through them. Therefore, they will also be having field around them. Now let us say around these conductors some free electrons because of radio and cosmic rays are present. Along with these electrons, there will be some air molecules which are neutral, now when we go on increasing the potential, difference between the two conductors, these free electrons around the conductors will get accelerated. When they get accelerated, they start moving faster and they collide with the gas molecules on their path. When they collide, they will dislodge electrons from these gas molecules, which means that around the current carrying conductor, that is line conductor, number of electrons will increase. Similarly here also. When collision occurs, electron will be dislodged. This process is known as ionization of air surrounding the conductor. Normally, the distance between the conductors is sufficiently high compared to their that is D is much greater than R. Therefore, corona occurs before flashover. If D is much smaller than R, in that case, corona may not occur before flashover, or very little corona may occur. Thus, the corona is a self-sustained electric discharge between the electrodes. Now these two are the electrodes here. For us, the line conductors which are transmitting the power are like electrodes. In practice, in order to avoid flashover means if the entire medium between the two conductors gets ionized, then there will be a current flow between the two conductors. That may be transient. And that current flow looks like an arc. And that arc is called as flashover. In order to avoid this flashover, usually the spacing between the conductors is kept much larger than R, and what practice is followed is D by R is greater than 15. That means the ratio of distance between two conductors to the radius of conductor is kept greater than 15. The discharge process depends on the polarity of the conductors, whether the conductor is positive conductor or negative conductor. But in case of AC transmission systems, the polarity of the two conductors keeps on changing alternatively. But in case of DC transmission systems, the appearance of corona is different because the polarity is fixed there for the two conductors. The positive wire shows uniform bluish white glow around it, whereas a negative polarity wire shows tufts or beads around it. And we can observe the corona in case of AC transmission systems by using an instrument called stroboscope. Okay, now we will write few lines on corona. If the potential difference is increased between two conductors spaced some distance apart in air at some potential of faint luminous glow of violet color will appear adjacent to the conductor. Surface with a hissing noise there is also formation of ozone gas if the conductor potential is increased further. The intensity of glow and noise will increase. This phenomenon is known as corona. Which is due to ionization of air near power conductor. Since free electrons are normally present in the free space due to radio and cosmic rays these electrons get accelerated due to the voltage of power conductors. And collide with other molecules of air and they dislodge electrons from molecules. Thus, the number of electrons increases. This process is known as ionization of air surrounding the conductor. Normally, the distance between the conductors is sufficiently high compared to their radius. Therefore, corona occurs before flashover. Thus, the corona is defined as self-sustained electric discharge between the electrodes. Here electrodes are conductors for us. Self-sustained electric discharge between the electrodes means it is a phenomenon which keeps on occurring on its own. You need not supply the energy from outside. Like in case of nuclear chain reactions, in practice, a flashover may occur with no or very little corona. If ratio of conductor spacing to the radius is less than 15, the ratio is always greater than 15 for overhead lines. The discharge process depends on the polarity of the applied voltage. However, in the case of AC, the polarity changes alternatively. In case of DC, means conductors transmitting DC power at unidirectional potential difference between them. The appearance of corona is different. The positive wire has more uniform bluish white glow and on a negative polarity wire tufts or beads are formed. The AC corona can be seen easily seen with stroboscope. In next class we will study critical voltage, critical disruptive voltage, visual critical disruptive voltage, and then we will solve some problems if sufficient time is there. I'll stop the class here. Thank you.